You are watching the lesson video on 3.4, More Work with Linear Functions. We're going to dive right in and just get right to the math. So with number 1, I would like for you to match the graph to the equations that you see over here. So pause the video and go ahead and match them. So here you see the answers. Notice how I used my y-intercepts to help guide me, which is this value right here on the end. And then I also used my slope to tell me whether or not the line should have been either increasing or decreasing. And that's the number that we see out in front here. So that 2/3 is positive, that 1 is positive, the 3/4 is negative, so that line would be pointing down. Same with the other one. Okay, moving on to question 2. Question number 2 wants us to find an equation of a line that meets the following requirements. So the first thing that I'm just going to write down is the equation of a line that we're used to seeing. Y equals mx, the slope times x, plus the y-intercept. So A says it passes through those 2 points. Well, I really like one of those points because it gives me the information that I need. That's my y-intercept. That's the point 0 up to. So right away, I know, well, an equation will always have the y and the x. So y equals m, that's what's missing, times my x, but I have the y-intercept already, so plus 2. Any idea how we're going to find the slope, that m? Well, if you said make a table of those 2 points and find the slope by dividing the change in y values divided by the change in x values, you are on fire. So 0, 2, and 7, 0. So how does 2 become 0? We subtracted 2. How does 0 become 7? We added 7. So now I can eliminate this piece here and just write in my slope. And if you want to, we can write it off to the side first. So that would be -2, change in y, divided by 7, change in x. So this equation would be -2/7 x plus 2. If we wanted to check this, we could hop to our calculator and graph and make sure the table shows these 2 points. Let's actually do that. Okay, let's graph. -2/7 x plus 2. And hit enter. It might be a little tricky to see, so I always like to look at my table by pressing Control-T first. And I'm going to go up the table, and as you can see, there's a point 0.02. Let's go down the table, and there we have the 0.70. So this is just a really nice way that we can use our technology to help check. Now 2b is very similar to 2a, except they gave us our points in function notation. So we still have 2 points. We have the points. In fact, let's just write them out over to the side. We still have the points 3, 0, and 6, -3. But they didn't give us the y-intercept like they did. They gave us an x-intercept, but that's not going to help me with my equation y equals mx plus b. So I guess let's just start and find the slope. So this is -3. This is +3. So my slope is -3/3, which is equal to -1. All right, so I'm going to write down y equals mx plus b, just because I know that's what I need to use. I know my slope now is -1, so let's put in -1 for the m. And I need to figure out b. I usually don't know x and y, but wait a minute, I have 2 x and y pairs. I'm going to pick the easier of the 2. I'm going to put in the point 3, 0, this point right here, x, y. And because I've done this, now I just have one variable to find, the b. That's exactly what I need. All right, let's solve this. So 0 is going to equal to, well, -1 times 3 is -3 plus b. And if I move the -3 over to the other side, I switch the sign, and I find that my y-intercept is 3. So now I have the slope. Now I have the y-intercept. Let's write our equation. Y is going to equal -1x plus 3. All right, jump to your Nspire. Let's check to make sure we are right. So we found the equation to be -x plus 3, or -1x plus 3, potato, potato. And I'm going to look at my table and make sure that the 2 points that they gave us, 3, 0, there it is, there she is, and the point 6, -3 exists, there she is again. So we know that we did this question correctly. Moving on to question number 3, it asks us to find the x and y intercepts of this equation here, and we need to show our work algebraically. Well, first, let's look at a picture of this graph to help us guide us to see whether or not when we actually show the algebra, if we made any computation errors. So let's see. Let's add a graph. And, this is weird. I don't have y equals notation, so let's think. I need to delete, and I want a relation now. Now I can type in anything I want. So 5x minus 7y equals 35. Okay, so it's pretty clear. I guess, well, it's a little difficult to see with this axis, but it looks like my y-intercept might be happening, wait, sorry, that's my x-intercept. Over here, my x-intercept looks like it's at 7, and my my y-intercept here looks like it's happening maybe at -5. Let's see. Let's find out if that's true or not. So remember, if I try to hit Control T, it's not a function, so my calculator will yell at me and say, hey, you gotta do the math. So let's go and do the math. All right, so how can I find this algebraically? Well, let's think about this. If I want to find my x-intercept, have I gone up or down at all? The answer is no. So my x-intercept, my y value, will always be 0. So let's find the x-intercept. We need to make y equal 0. What do you think we'll do for the y-intercept? Well, we won't make the y equal to 0. We will have to make x equal 0. So let's show our work 2 different ways. So the x-intercept, I'm going to take my equation, 5x minus 7y, but instead we're going to put in 0 for y, set that equal to 35. Let's do a quick solve. That becomes 0, so I would be doing 5x minus nothing. I'm not even going to bother writing that. Equals 35. And divide both sides by 5. Simple one-stepper. We get x is equal to 7, which is what we predicted right over here. Sweet. All right, let's do the same thing now, but just find the y-intercept algebraically. So x will become 0. 5 times 0 minus 7y is equal to 35. So we just used our original equation and made x 0. Well, 5 times 0 is 0, so we're left with negative 7y equals 35. I could have written 0 minus this, but why bother? Divide both sides by negative 7, and we get y is equal to, oh my goodness, negative 5, which we saw over here on the graph. So look at how nice this graph is as a checking tool. Moving on to the next page, it's basically an entire page of asking whether something is or is not a solution. So in order for something to be a solution, it has to either make the table true, the picture true or the function itself true. So if it's a solution, the point lies on the line. If it's not, the point does not lie on the line. So let's just find the point that they gave us. It looks like they did this one for us, but let's verify. The point -1, 4. Nope, it's not, because it doesn't lie on the line. How about the point 3, -4 here? Yes, it is, because it lies on the line. 2, -2? Is that a solution? No, it's not. It doesn't lie on the line. And how about 4, 1? Yes. And yes, put the exclamation marks. Say it loud and proud. All right, let's go down here. Okay, if it's a solution, obviously, I don't think that this is anything earth-shattering. If it's a solution, the point should lie in the table somewhere. So sometimes you might see the point, sometimes you might have to find the point by either going in between the points or continuing the table. So 1, 2, it says it is a solution to this table here, but is not a solution to this table. I think this one right here is a little bit easier to follow the X pattern, because if we just carry this on, or carry it on down, sorry, I'm writing over things, and we did the same thing with our y, so -3, -2, -1, 0, 1, 2, 3, 4, we can see that it's actually the point 1, 4 that lies on the line. Now here, the point 1, 2 falls in between right here. Let's see if that pattern is consistent. So my y values, if I wanted to put points in between those, so -1 and 3, what is my pattern? Well, right now it looks like I am adding 2 when I jump to my x's. So if I go halfway there, I only have to jump 1. So -1 to 0, 0 to 1, 1 to 2, 2 to 3, 3 to 4, and then we can see, yes, the point 1, 2 does fall in there. Okay, let's look at D here. Where is that point 0, -5 in this table? Well, it looks like we have to continue this backward, so 2, 1, 0. That was really easy to see that pattern. And what's going on here? If I count backwards, it looks like I'm losing 2 every single time. So this would be the point 2, -1, 1, -3, 0, -5. So the answer is yes. Okay, let's try this -2, 11. This is kind of weird. So it looks like we have some x values and y values, but nothing seems to kind of stand out to me right away. But let's think about it. How could I go from -6 to -1? Looks like I added 5. How did I go from -1 to 4? Well, I also added 5. Now I see the pattern. I'm adding 5 to all my x's, and then what is happening with my y's? Well, it looks like every single time, hey, aren't I adding 5 again? So this is funny. My slope here is actually just 5 over 5, which is, isn't that the same as 1 over 1? So I have a slope of 1. So if I continued my pattern between -6 and -1, where this -2 falls, let's do this up here. And I'm going to write my table sideways. I am running out of space. So -6 for my x, and my y is -7. Let's follow this pattern. So this would be -5, -4, -3, -2, and let's just put -1 in there to make sure that we didn't make a mistake. But if I count by ones, I can count by ones in my y's as well. So 7, 8, 9, 10, 11, 12. Hey, there's the 12 I was supposed to end up with. And is -2, 11 in the table? It sure is. So this one was pretty tricky. but super fun. Okay, moving on to the last section. We need to know if a point is a solution to the function. So if you see this example that they provided us, we can see that all we're doing is putting in the point, the -1 for the x value, and 1 for the y value. So let's go ahead and do that here. If it works out and it checks, we know it's a solution. Yeah, we're happy. So this would be 3 times 2 plus 2 times 1 is my y, should equal 6. So is 6 plus 2 6? No. 8 does not equal 6. So no, it's not a solution. How about for part G? Is 2 times, this is my y value, minus 3, should equal 3 times my x value, which is -2, plus 7. So 4 minus 3 should equal whatever -6 plus 7 is. Is that true? Well, 4 minus 3 is 1. -6 plus 7 is 1. Yes, this is a solution. So if I graphed it, I would see this point in the table of values. All right, let's move on to H. And just so I'm running out of space, I'm going to show this in a different color. So 2 times my x value, which is -2. There's my y value of 1. So -2 minus 3 is going to equal 3 times my y value of 1 plus 3. I could distribute if I want, but I'm going to simplify. So 2 times -5 should equal 3 times 4, and -10 does not equal 12. So no, this is not a function. You were saved by the bell. Hope you enjoyed this lesson.